Hello guys, I'm back. My name is Jeferson Costa and I teach students, graduates and engineers how to work with chemical process engineering and plant design. And today I am here to show you in the brackets the quote garbage in, garbage out. What happens when you don't know what you are doing in your process simulation software. In my screen you can see a process simulation for the upgrading of biogas to biomethane using water scrubbing or water wash process. In this process, we wash the biogas with cold water at high pressure in order that the water is responsible for removing the CO2 from the biogas, and in the top of the absorber column, this one we get here pure biomethane or very purified biomethane. And after that, we need to do some processing to dry the gas to inject in the gas grid. And this kind of process, to have the best results in this kind of process simulation, we will not use the equation of states, the equation of state, for instance, the Penge-Hobson, because it do not get, or we don't get good result with that. In this case, we will use the NRTL fluid package that is based on the coefficient of activity. So they are more empirical correlations that you get in your process simulation, the results of your process simulation. So when you start your process simulation on Aspen High Seas, you need to add your components and you need to select your fluid package. And in this case, as you can see, when I click in the NRTL, by standard, the vapor model for this fluid package is the ideal. And what happens with the activity model is that they simulate only the liquid phase of your process stream. To the gas phase of your process stream, you need to choose a vapor model. That can be ideal, RK, PR, Penge-Hobson, and others. So if you start your process simulation from scratch and choose NRTL, that is the best model or the best fluid package for simulating the water scrubbing, you will get the vapor model as ideal. So when we return to the process simulation, it's important to you understand the fundamentals of chemical process engineering in order that you are able to evaluate the results of the process simulation software. So we know by the fundamentals of the thermodynamics that when we depressurize a hydrocarbon, it's normal that we decrease the temperature of this hydrocarbon. So if I have here biomethane at 80.5 bar G, when I depress that to 0.5 bar G to recirculate this stream to my compressor, I must have a decrease in temperature in my valve here, because this valve is responsible to breaking the pressure from 80.4 bar G to 50 millibar G. And you can see here from the results of the process simulation and using NRTL ideal gas phase model that the temperature of my biogas, my biomethane, is 6.5 upstream of the control valve at 80.4 bar G, and it keeps as 6.5 Celsius degree at 50 millibar G downstream of the control valve. So it means that although for the liquid phase of the process I get good results with the NRTL, I cannot use the ideal for the modeling the gas phase, because in fact I'm not having consistent results with the ideal model for the gas phase. So how I can solve that? What I need to do to solve that? First, when you are reading papers or articles, take a look on this when you are verifying the heating material balance on papers and articles, and when you are verifying also the process simulation that you are doing or of someone are doing. But to solve that is very simple. We need to return to the properties, and in this environment I am able to choose another vapor model for my process simulation. So instead of using ideal, in this case I will use the SRK, because this is most acceptable for all kinds of gases. So when I do that and I return to the process simulation, now the Aspen High-Seas will perform the calculations again, and you can choose if you will return to the simulation environment on holding, or if you will perform the calculations automatically return to that. So I will click on no. And when I do that, the Aspen High-Seas will perform all the calculations again. And now let's verify what happens in the pressure drop in my valve. So upstream of the valve, I still have the 6.5 Celsius degree and 80.4 bar G upstream of the valve, because this is part of my specification for the biomethane. But now downstream of the valve, I have 2.06 Celsius degree and 50 millibar G. That makes much more sense in real life than using any RTL with the ideal gas phase, or the ideal to model the gas phase. So take a look on that, because what you get from the results of your process simulation when we are talking about plan design will be used to purchase equipment, to start production, and to make profits for your company. And if you get wrong results from your process simulation and specify equipment with that, you can mess with the production and not get the expected results from your process, and that will not be good for anyone, not for you, not for the company. If you like this video, share it with other chemical process engineers or in chemical process engineer groups, because this way you will help me to achieve 100,000 chemical process engineers around the world. So guys, this is it. I hope you like it, and I'll see you soon in the next video. Bye bye.